Hello friends, in the previous videos we looked at a few numerical integration methods such as trapezoidal method, simplex 1/3 rule, simplex 3/8 rule as well as Gauss Quadrature 2-point formula. In this video we are going to look at yet another method called Gauss Quadrature 4-point formula, which is similar to the Gauss Quadrature 2-point formula that we have seen before. Our objectives are to numerically integrate a function using Gauss Quadrature 4-point formula. Gauss Quadrature 4-point formula is an efficient method compared with other methods such as trapezoidal or the simplex 1/3 and 3/8 rules. The strategy for Gauss Quadrature is as follows. If you look at figure 1, we would like to find the area under the curve f of x. So we approximate it by drawing a straight line between these 2 points, the dotted straight line. So the area below the dotted straight line reflects the area under the curve. This is the trapezoidal method. And by looking at that, we know this is not very accurate because there is a good amount of area above the dotted straight line and below the curve that is left out. So to avoid this error, the Gauss Quadrature strategy is as follows. We pick those 2 points strategically so that and draw a straight line through them that intersects the vertical lines from A and B. By looking at figure 2, we find that the area below this dotted straight line is more close to the area under the curve. This is because if you look at either sides of the curve, the area below the dotted straight line and above the curve on either side, they cancel out the area between the dotted straight line and above the curve in the center. So this is the Gauss Quadrature strategy. And looking at the Gauss Quadrature formula, we have I equals integral a to b f of x dx, which is equal to sigma I equals 1 to n ci f of xi. And integral a to b f of x dx equals b minus a over 2 times sigma I equals 1 to n ci uppercase f of ti. Here we need to do a coordinate transformation from xi to ti as shown below. We evaluate parameters m and c as shown, where m equals b minus a over 2 and c equals b plus a over 2. And x equals mt plus c. Here we replace f of x by f of t by substituting the x value, which is x equals mt plus c, into the f of x equation. The Gauss Quadrature 4-point formula, we have the constants c1 to c4 are given as shown, and these are fixed. The Gauss Quadrature points t1 to t4 are also fixed and are given as shown. To illustrate the Gauss Quadrature 4-point formula method, we'll do an example. We would like to integrate the function f of x given here between the limits a equals 0 and b equals 0.8. The value obtained analytically is 1.640533. We look at the MATLAB code for this Gauss Quadrature 4-point method. The function f of x is given here, and the parameters m and c are given, and x equals mt plus c. So we have to find out the function ft by substituting x equals mt plus c. And the Gauss Quadrature formula is here. I equals m times the sum of Ci times Fti. The limits are a equals 0 and b equals 0.8. The constants C1 to C4 are given, as well as the Gauss Quadrature points T1 to T4 are given as well. When we run this, we get a value I equals 1.640533, which is about the same as the value we got when we solved the problem analytically. So just by using 4 points, we can get very accurate solutions. To summarize, we presented Gauss Quadrature 4-point formula to numerically integrate a function of fx. And we notice that the Gauss Quadrature 4-point formula yields very accurate solutions when compared with the trapezoidal, the Simpson's rules, as well as the Gauss Quadrature 2-point formula. In the next video, we can look at some methods for solving ordinary differential equations or ODEs. Thanks for watching the video. If you have any questions, please post it. I will be uploading the codes in the YouTube section at some point of time. Thank you.